Hello, welcome to Fun Online Teaching and Learning, another session and learning session about systems thinking. If you like the content, please like and subscribe to YouTube channel Fun Online Teaching and Learning if you like the content, so that we can create more content like this. So today I will talk about how we avoid hasty decisions using systems thinking. So systems thinking to the rescue. So today's agenda is I want you to leave the linear thinking behind, right? So I want you to adapt systems thinking, understand system triangle, to be able to identify if systems around you are collections or just stuff, and what is systems thinking. And I'm gonna provide some tools to use when thinking in systems. So I highly recommend these books. If you are embarking on a journey about systems thinking, I would like you to know about INCOSI. That's the International Professional Society about Systems Engineering. And I highly recommend to read The Fifth Discipline by Peter Sanjay, and then Donella Meadows, Thinking in Systems, and then John Moorcroft's Strategic Modeling and Business Dynamics. I am also including two links here. One is for INCOSI Professional Society, and the other one is by an entrepreneur and Professor Laila Karaulu. So it's a great website if you want to visit. So I would like to start with talking about the decisions, right? So there are many quotes that we can mention about the decisions and the quality of decisions. For example, Lewis Carroll said, "In the end, we only regret the chances we didn't take," right? And Albert Camus said, "Life is sum of all your choices." So choice means decisions, right? When we make decisions, we actually design our life and live our life. And one of the worst things that we can do is not to decide on something which is not really applicable in real world. So we have to have choices. We have to make decisions about the choices. So how can we then increase the quality of our life? Well, we can increase the quality of our life by increasing our quality of decisions. And how can we increase the quality of our decisions? Well, at that point, systems thinking to the rescue. We're going to get some help from systems thinking. So when we talk about the systems, I want you to visualize a cashier, like in this picture, okay? I want you to think of, and if you can comment below, I'll be really happy as well. I'm going to say the things that I am thinking about what kind of a system is this and what are the parts and relationships, but I would be happy if you can comment below as well. So this is a regular cashier's checkout, self-checkout station, right? You can find any grocery store nowadays. And I want you to think of parts of this system. For example, when you think of parts, if you are thinking in systems, you see the parts that are not only physical and visible as well. For example, I can see there's a screen here, there's a swipe credit card station, point of sale POS, right? There is probably if you're buying tomatoes, and well, it can ask you how many, but you also need to weigh some of the fruits and vegetables, right? So I can see there's somewhere you can put in your password, There's a place that you can use the plastic bags, but there are also things that are not visible here. For example, this little screen talks to the inventory of the grocery store, right? It talks to the banks, because when you swipe your credit card, or it must talk with the banks, right? So it should be integrated into banking system. And when you wait, it should be able to wait correctly, and also it should be able to calculate the tax correctly. So if there's no tax on an item that you purchase, so as a systems thinker, you should be able to see the invisible, not visible parts and relationships as well. Okay. So also in the self-checkout counter, think about the parts, properties, relationships. For example, I said this point of sale should talk to your credit card and should talk to bank correctly. And then there are requirements that needs to be considered. For example, can the customer purchase alcohol, right? Or cigarettes or stuff like that. And what are the related systems? For example, this self-checkout cashier or counter talks to the customer. There are employees over there, and there are blinking lights. There are errors that needs to be corrected, and what functions are performed, right? So when we talk about systems thinking, we should be able to identify all these different parts. So as you can see, even a little tiny self-checkout counter actually can be considered as an entire system. So designing that system, having systems thinking philosophy and application in the designing of this self-checkout counter is very, very helpful. So it's a lifelong practice. If you obtain systems thinking, really, like, it's really difficult to unlearn it. So it becomes a part of a second nature of you, and then everywhere you look, you look systems thinking, and you practice it lifelong, not only your professional life, but also your personal, family, and social life as well. I highly recommend. I can't really make you watch this video because of copyright issues, but I highly recommend listen to Russell Ackoff. He's a modern systems thinker, about the properties of systems and then how he identifies the system with his own way. I highly recommend you to watch this video. So in the beginning, I told you leave the linear thinking behind. For example, studying at an exam, right? You got a low grade. What do? Please write in the comments. Yeah, probably you say you study harder, right? You study harder. But are you studying smarter? Are you studying the correct topics, right? Are you engaged with the teacher? Are you engaged with the content, right? Are you on top of everything going on in the class or in the book, right? So just studying harder is not gonna secure you a better grade. For example, when in terms of traffic congestion, right? There's congestion, right? Like you see in this photo. Okay, so what do? We built new roads, right? In systems thinking, probably the first solution that comes to your mind is not really the best solution, because when you build new roads, now you have very crowded new roads, right? Why? Because when you think in systems, think about it. If the country has more lanes and better roads, what's going to happen? Well, people who doesn't have cars will purchase new cars because it's very convenient, it's quicker, it's cheaper. So they will discontinue using public transportation, right? So you will, because of the new lanes and better roads, you'll see more cars, and you'll see congestion back again, right? So you have to solve this in a little bit smarter way. What can you do when you're thinking systems? For example, yes, you can still build roads, but you can encourage people to carpool. You can give people, the companies can provide some incentives to use public transportation so the employees don't use the cars, right? You can implement some policies that the cars after a certain age, they are not allowed in the traffic, because when they make an accident, a crash, it's high likely to contribute to congestion, right? And maybe you can again implement some rules and policies and say, like, for example, the trucks, 18-wheelers will not be able to enter or take these exits, right? Maybe they are in the center of the city and the trucks are not allowed to take those roads. So that's all gonna contribute uh, to the better roads, right? Better traffic congestion, because in this problem, it's the problem is not roads, it's the traffic congestion, right? So you should we should think in a little bit bigger perspective. So instead of linear thinking, I want you to acquire event-oriented worldview, right? So in the event-oriented worldview, there's a goal and situation, and there's a discrepancy. For example, you have a goal, and then you have a goal to take a good grade in the exam, right? And then you study, and then situation is you get not a really good grade or not a goal. So there's a discrepancy, right? What do you do? Well, you make some decisions for the next time. As I said, study smarter, not only harder. Be on top of things. Contact your teacher. Go to study a little bit more, and support your study with maybe YouTube videos and other resources. And then after your decision, what do? You take action, right? And there are some results. So this event worldview, which is the linear thinking, what do you see here? What is missing here? Well, the missing is the feedback loop. So this event-oriented linear thinking behaves like in our lives. There's only one event, there's only one discrepancy, and there's only one decision, and there's only one result. However, that's not the case, right? The world is more complex and more VUCA than that. So that's an event, but the solution is not a fix. So because things and solutions and implementations, our decisions are not happening in a vacuum, and there's no one situation that we need to decide. There are more. So which means on the left, you say traditional thinking, right? One event and one problem and one solution. Whereas the systems thinking, you have multiple feedback, you have different loops that connect the same nodes and stuff like that. So I want you to move from traditional thinking to systems thinking, which will make you more successful and more promotable. Okay? So then what is the feedback worldview? So just a little bit tweak when we were drawing the linear thinking as problem and fix, right? Instead of just drawing it linearly, I want you to draw like this: goal, situation. Now there's a discrepancy, right? This is a problem. This is the same thing. I just use a little bit curvy lines, and then decision, and then action and result. However, because I kind of presented that in a loop kind of a picture, right? Now you can understand and guess what is missing in this picture. I'll pause a few seconds. What is missing in this picture? How can we complement this picture? Well, we can complement this picture easily. This solution, so action and result feeds back into situation. So just the example that I gave you, you got a little bit lower score than you aimed, right? Your goal. So this result, what does it do? Well, it feeds into the situation, and it impacts the discrepancy. So your discrepancy will be a little bit lower, right? So it's improved, but it's not zero. So then you make the same decision, the similar decision to study harder, and then now you have new action. However, what is this yellow thing? This is feedback, right? The decisions we make, we take actions, and then actions have results, and they have multiple results, right? And then they feed into situation. So if this loop is broken, and if you don't consider the feedback, it's like a blind person, right? You don't know where you're going. There's no feedback, right? So, however, systems thinking adds on top of this picture, not only creating feedback, not only drawing a little bit curved lines, it also considers that action and results creates new decisions, new results, and they are all interconnected and intertwined. It's harder to solve these kind of problems, but that's the world we live in. So we also must consider in systems thinking second and third order effects of our decisions, because there will be unintended consequences. When we act on something, when we do something, there will be effects that we didn't really consider, right? They will cause maybe new problems. They will add new layers to the problem and the situation, and will add to our discrepancy. And I love this cartoon a lot. right? So you don't want to, in these situations. And also, you don't want to be in this situation, right? Every time you push a slab, the slab will might collapse on top of you coming from another direction, right? Say you send an email to somebody, you never know whose desk or inbox the email will end up. Okay, so you write an email to someone in the company complaining or saying bad words, and then he forwards it to another one, and then they forward to your manager, and then your manager comes back to you, right? So just like in this picture, because we really need to understand the systems thinking, because being naive and not being aware of the systems thinking and systems, it's not gonna help us. For example, it's not gonna change the result. So if you don't know the system, how come you make good decisions? Okay, for example, I have a bestie, right? So they put in unintentionally, kind of maybe a poison or something, right, in my coffee, and then uh, I have a bad actor who wants to put poison in my coffee, right? Guess what? What is the result? Well, the outcome is the same. I'm injured, right? I'm hurt. So it doesn't matter my friend not knowingly doing it, and my the bad actor really wants to do it. The result is the same. So every time we all live in systems, right? You gotta know your system. You gotta know your parts. You gotta know your relationships of the system, the objectives of each part and system, right? Then what is a system? Let's cover that in the next video. Okay? And if you like the content and if you want to see more of these, please subscribe and follow the content, and turn on the notifications, please. I would really happy to see your comments below, because I read all the comments. Thank you.